I can graph the parabola. Start with negative b over 2a. I can graph the parabola. Start with negative b over 2a. Alright, stop. Let's plot the vertex. Negative b over 2a gives x. Y comes from plugging in x, evaluate the sum. What do I do next, yo? I know. Draw the axis of symmetry so it passes through the x-coordinate of the vertex. Make a nice mirror so your points reflect. Next, let's fill out this curve. Pick two x near your vertex you observe. Any's okay? Yeah, that's true. But pick a nearby so it's easy, fool. Plug in those x's to find your y's. Plot them and reflect on the other side. If there was a problem, yo, we solved it. Draw the curve as the arrows itself. I can graph the parabola. Start with negative b over 2a. I can graph the parabola. Start with negative b over 2a.
Alright, well, welcome back, Algebra 1 students. And that's exactly what we're going to be looking at today, is graphing a parabola again. We've been doing that in Chapter 8, learning how to graph a parabola. We started to build from the very beginning. We were just looking at the ax squared part. And then in 8.2, we added in the c part. And now we're going to add in a full trinomial here with ax squared plus the bx plus the c. So this bx part does add a bit of a different component to us and makes things a little bit more difficult in graphing these parabolas, but we can still get them done fairly easily, without a whole lot of pain and misery and suffering. So that's what we're doing here. We're graphing these functions. We're also going to be looking for what's called maximum and minimums of the values, maximum and minimum values of these quadratic functions. And if you were to see those kind of pictures of the parabola shapes, you know, there was the one at the very beginning with the motorcycles. So the maximum and the minimum functions would be the very highest point that that motorcycle maybe would be getting as it, you know, flew through the air. All right, let's go ahead and look at our cartoon of the day. So two guys sitting out in a little raft in the middle of the ocean. Okay, crybaby, you want the last soda? Well, let me get it ready for you. He starts shaking it up. I love that one. All right, Far Side's always good for a laugh. All right, as we get into our core concept on page 257 in your journal book in the notes, we'll see a few things here on graphing in this form where we have all three terms here. We have a trinomial, so we have the ax squared part, which makes it a quadratic. The x squared part of this, the highest degree here, is a 2, so that makes it a quadratic. But then everything else after this, we have a bx term and a c term, a constant term. So what we're going to be doing here is, first of all, seeing which way is it going to open. That's really going to help us. Is it going to open up like this one's showing, or is it going to open down where the arrows are pointing down? So how do we know if it opens up or down? Well, it's based on your a number, the number in front of the x squared. If that is a positive number, it's going to open up like this one here. If it's a negative number, it's opening down. It's essentially what this is saying. A is greater than 0, positive, opens up. So that's what this is saying. This means positive right here. And then A is less than 0 means negative, and that means it's going to open down. Another thing we can identify on this graph using this form here is that the y-intercept is C. So that C, whatever that is, that's going to be our y-intercept. It's going to cross through right there at the y-axis. So that's easy to see. One thing is easy to see is you can always understand the y-intercept. It's that last constant number, because a y-intercept is always plugging 0 in for x. If you do that here and here, it basically puts those terms both to 0, and the only thing you have left would be c. Now we need to find the most important point to find, which is our starting point in graphing any parabola, is going to be this vertex down here. We need to know what this point is right here, and the way we find that is we first need to find the x-coordinate, and we do that with this little kind of formula right here of negative b over 2a. So here you have your a, your b, your c. So it's always going to go like that, and we're going to be talking about ABC and quadratics quite a bit, even in this chapter and the next. But the B, the opposite of B, so really it kind of goes opposite of B over 2a. So negative B over 2a. So whatever B is, opposite of that number over 2 times the a number, whatever that is. That would give you what your x-coordinate is. And then to find the y, basically what you need to do here is you need to plug in to find y. So it doesn't say about y here. So the x-coordinate of the vertex is this, but to find the y of the vertex, so y-coordinate, we got to plug in. So this is for the y-coordinate. I'll just put coordinate like that. You got to plug in the x back into the function. So we plug in x. So that's what we're going to have to do here. Plug in x to find out what that y-coordinate is. That will tell us this ordered pair here for the vertex, what that is. We also know something here as far as the x-coordinate. Whatever that is, we can say that's the line of the axis of symmetry, which goes straight right through the vertex, and it's going to cut this parabola into 2 symmetrical equal halves. And so we'll see that as well. All right, let's move into looking at our extra practice. So page 258 here of your extra practice, 1 through 4 wants us to do 2 things. A says we're going to find the axis of symmetry, and B says find the vertex of the graph of the function. So first of all, look at number 1 through 3, and then you can do number 4 on your own. So number A, or letter A, the axis of symmetry is always going to be an x equals like this. It's always a line of symmetry, which is x equals, which is a vertical line. And to do that, we need to know that it's going to always be negative b. I'm going to put it right up here again. Negative b over 2a. And I like to put the negative with the b. You can put it out in front, but I like to keep it with the b. And this is always x equals this. So here's our a, our b, and our c. So a would be 1 right there. That's our a. B would be negative 10. This is our C. We don't need that right now. We're just looking at A and B. So the opposite of B. So 10 is negative. So the opposite of negative 10 would be a positive 10 over 2 times A, which is 1. And so that's going to give me 10 over 2, which is 5. So my axis of symmetry, right here, letter A, the answer for that is just x equals 5. Now that axis of symmetry is also the same number as the x-coordinate of the vertex. So letter B, we already know the first part is 5 comma whatever the y is. So now we got to figure out, okay, what is the y going to be here for the axis, for the vertex? That's the vertex is that highest or lowest point. So using this function here, we're going to plug in 5 in here for x. So it's going to start off with 5 squared. And actually I'll start off with y equals this just because we're looking for the y-coordinate. So y equals 5 squared and then minus 10 times 5 plus 2. And so we're going to get 5 squared, which is going to be 25. And this is going to be minus 50 plus 2. And so we can say 25 minus 50 is going to be negative 25, then plus 2. And it's going to take 2 away from negative 25. It leaves me with negative 23. So it should be 5 for x, and the y-coordinate is negative 23. There it is. That's how we find the axis of symmetry and the vertex of our quadratic. Looking at number 2. For finding the axis of symmetry again here, we're going to say x equals, and it's going to be opposite of b. So again, a is here, b is here. 16 is b. We don't have a c, so c would actually be 0. If we needed to put in a c number somewhere, that would be 0. So b is 16. Opposite of that would be negative 16 over 2 times a, which is negative 4. So we're going to get negative 16 over negative 8. Negative over negative will be a positive number. 16 divided by 8 is 2. So our axis of symmetry is going to be x is equal to 2, which is also the x-coordinate of the vertex. So you find the axis of symmetry, you've also found the x-coordinate of the vertex. And now we got to plug 2 into this function to find the y-coordinate for the vertex. So for letter B, y equals -4 times 2 squared, and then plus 16 times 2. So we do the order of operations here. We're going to do the exponent first. 2 squared, so it's going to be -4 times 2 squared is 4, plus we can do 16 times 2 over here, which is going to be 32. And then we can see -4 times 4 is -16 plus 32, and that's going to end up equaling -16. Take it away from 32, that's going to be +16. So the y-coordinate here is +16. So 2, 16, that ordered pair would be our vertex. That's our starting point when we want to graph it. So that's why we need to know this information, so when we get to graphing them, we're going to have to find this as well at that point. So we need to get really familiar and good at mastering how to find the axis of symmetry and the vertex. All right, number 3, finding the axis of symmetry here, letter A, x is equal to, again, -b. So b here would be -8. So opposite of that, you can also do it this way, negative times -8. If you want to do it that way, that's fine. I like to just sometimes say opposite of that number, but it's negative times b, and b is -8. 2 times a, 2 times a is -2. So this is a double negative, so it's a +8 now up there. -4 is down below. And 8 divided by -4 is going to be -2. So our axis of symmetry will be x is equal to -2, which is also the y-coordinate of our vertex. I mean the x-coordinate of our vertex. We need to find the y-coordinate now. So b, y is equal to, so it starts out with -2 times x squared, so times -2 squared, minus 8 times a -2, and then plus 5. So -2 squared, that's going to be a +4. So we're going to get -2 times +4. And then negative times negative will be a positive. 8 times 2 is 16, plus a 5. This will give us a -8 plus 16. Actually, we can put 16 and 5 right now together. 16 plus 5 would actually be 21. So we can do that. And then take 8 away from 21. That's going to be, what, 13. Positive 13, because the positive number is bigger. So we should get a -2, 13. Alright, so go ahead and pause the video at this point. Now that I've done 3 of them for you, try number 4 on your own. See if you can find the axis of symmetry and the vertex on your own. And then play the video just to check your answers. Alright, so let's check to see if you were able to get this correct. I'm just going to show the answers right now, and then I'll show you how to do the work. But your answer for A, which was the axis of symmetry, should have been x equals 1. And that was also the first number of the ordered pair here on letter B from the vertex. And then the y-coordinate of that is 4. So 1, 4 would be your vertex. So finding the axis of symmetry would have been doing -6, okay, opposite of this, -6. 2 times -3. That's going to end up with a -6 over -6, which is going to equal +1 then. Plugging that 1 back into your function to find the y. So you got negative, so 1 squared is 1, and 1 times -3 would be -3. This is a 6 here. So you're going to get -3, and this is 7. So you can do 6 plus 1 is 7. You're going to get -3 plus a 7. It's a +4. All right, so let's move on to our next section, as we will keep using this and building upon this. Okay, so number 5 through 7, we're now going to actually be graphing the function, but we do need to first find that vertex, the axis of symmetry and the vertex. Now I didn't list the axis of symmetry down here. I've listed the vertex, that's the starting point. We can obviously draw a line through our vertex, a vertical line through it, for the axis of symmetry. So you can just think about, I need to find the vertex. That's the first step to do in graphing this. It says to describe the domain and range. We'll look at that once we've graphed it. All right, so finding our vertex, we need to find the x-coordinate, the y-coordinate. So to find the x-coordinate, That's the same thing as finding the axis of symmetry. So negative b, so b is 6, so it's going to go negative 6 over 2 times 3. 2 times 3. And so that's going to be negative 6 over 6, which is going to give us a negative 1. And then to find the y-coordinate, we're going to plug negative 1 back into this function, those two places. 3 times negative 1 squared plus 6 times negative 1. So negative 1 plus 2. So negative 1 squared would be a positive 1. Two negatives make a positive. So 1 times 3 would give us 3. This is a negative 6 here, and then plus 2. We can do 3 minus 6. That's going to give us a negative 3 plus 2. And that's going to give us, take 2 away from negative 3 is a negative 1. So our ordered pair for the vertex, put it right here, x is negative 1, y is negative 1. They're both negative 1. So that's the first point we need to plot. So everything is going to be 1s here, so every box is going to be worth 1. So 1, negative 1, negative 1 will put me right here. Okay, now another thing we want to know is which way is this going to open? Is it going to open up or down based on the a number? Since a is positive, I'll just put POS for positive. Okay, it opens up. Since a is positive, it's going to open up this way. Okay, so now what we can do is we can pick some points on each side of this vertex. So we could pick 0 for x, 1 for x, 2 for x. We can do that because we can plug those numbers also into our function here, just like we did with negative 1, and find ordered pairs. And using this axis of symmetry, which I'm going to use kind of a green line. So right through the vertex here is this very straight line. This is our axis of symmetry. We can use that as well. So this being our axis of symmetry. Whatever points we get on this side, we're going to put them also on the other side, and that would make it symmetrical. It's going to be a U-shaped parabola. Now, that's one way we can do it. We can do a table of values and try to come up with ordered pairs here, plugging 0 in for x. So I could do it this way, x and y. Plug 0 in for x. I could plug 1 in. I could do 2, and then just find out what those are. In fact, 0 is very easy to do. Because if we plug in 0, that makes that 0, that makes that 0. So 2 is 0, 2 is your y-intercept. So 0, 2 right there we know is a point. That's a point on our graph, which is 1 away from the axis of symmetry this way, so 1 on the other side would put us right there. So there's a starting point of that. Now we can kind of use that, but I think we should get at least 1 or 2 more points to help us get more of an accurate view of this. What we can also think of is there is an A, our A number is 3. This is a parent pattern with the A. So the A number, parent pattern. Now this is my own thing that I've just kind of figured out myself. To make graphing these parabolas a little bit faster and easier. The A number parent pattern. So 3 is our A number on this one. A is 3 here on this one. The parent function, remember, if I was to kind of graph a parent function, we'd start at 0, 0, and then we would go 1 to the right, and we would square that number because we're going to square the x. Whatever we put in for x, we're going to square it. And remember the parent function is like f of x just equals x squared. That's our parent function. So if I just square 1, that's going to give me 1. If I do 2 and I square 2, it's going to give me 4. If I do 3, it's going to become 9. 3 squared is 9. That's our parent pattern there. Well, we can kind of do the same thing with our a number on any function here, especially in this form. We can use this pattern. So if we're going to go 1 from our vertex, and you can see how this will work out on this one. If I go 1 from the vertex here, 1 would be, so now basically I have this. I have a 3x squared for this one. So you plug in 1, that is 1, times it by 3, that's going to be going up 3. So 1, I'm actually going to go up 3. Okay, so I go 1 to the right, I plug in 1 for x, that's 1 times 3 is 3. That means that tells me how much I'm going to go up. So I'm going to go from here, I'm going to go up 3. 1, 2, 3, and that puts me right at that point. And I can figure out using axis of symmetry, going the other way, 1 this way, it's going to go up 3 as well. So if I go 2 this way, so 1, 2, now I'm over here at positive 1 for x. If I go 2 this way and I plug in 2, 2 squared is 4, and then 4 times 3 is going to be 12. I would need to go up 12 here. So 1, 2 this way, I'm going to go up 12. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So right here is 9. So that means I have not gotten to this point, so my graph is going to go through a little bit less than here. It's going to be right there. It says 12 is going to be like 10, 11, 12. We're kind of way up here on 12. So same thing here. As I go 2 this way, we're going to be going all the way up and just a little bit less than that at the top of this window for the graph. And so I'll go ahead and plot these points. I can start this one, kind of come down, go through this point. Remember, this is a U shape, so I'm going to kind of do a curve there at the bottom and then kind of come back up and go through those points. And I'll put arrows on the ends. So that's not as pretty as maybe it would be done on a graphing calculator, but that's essentially what it is. All right, let's come to number 7, and I'm going to have you try number 6 on this one. So same thing we need to do is find the vertex first. So finding the vertex, start with x equals. So opposite of b. So b in this one is -1. So we can say negative times -1 over 2 times -1/5 is our a. -1/5. This is definitely going to be a more challenging one. So we're going to get 1 on the top, and then -2/5 will be on the bottom. Okay, so basically what this is saying right here is like this. It's really saying 1 divided by -2/5. Whenever you divide with a fraction, you can multiply by its reciprocal, so it's 1 times -5/2, 5/2, and 1 times anything is just what it is. So it's -5/2. So let me start with our x-coordinate over here. It's going to be -5/2. And it might be actually easier to do that as a decimal. 5/2 would be like 2.5 or 2.5. So it's probably going to be easier to actually see it as a decimal. So let's put 2.5 here. Okay, so now we got to find our y-coordinate. So we're going to put the -5/2 in, so that's why it's a little bit challenging when it's got a fraction. So we have the -1/5 times -5/2 squared minus -5/2 and then plus 5. So when you square a fraction, you're going to square the numerator and the denominator. It's going to be a positive 25/4. So you're going to end up with -1/5 times 25/4. Over here it says negative times negative, so it will be a plus 5/2 and then plus 5. Alright, so I'm kind of running out of space. I'm going to have to come over on this side a little bit. When I do this, I'm going to multiply here. So this is going to be negative times positive. So we're still going y equals here. So it's going to be negative, and then 1 times 25 is 25, over 5 times 4 is 20. So really we need each of these to kind of be in 20ths to be able to work this out. So 5/2 in 20ths, I would multiply by 10, so that's 50/20. So plus 50/20. And if I think of this as 1, 5 over 1, let's see, 20 times 5 is 100, so it's going to be plus 100 over 20. Okay, so I know when I take away 25 from 50, I'm going to get 25 and then add 100, 125. We're looking at 125 over 20. And we want to figure out, okay, well, what is that as maybe as a decimal. So as a decimal, we could do it on a calculator and just say, oops, 125 divided by 20. So that's 6.25. So let's put that in an ordered pair here. 6.25. Okay, so now as we do this, also we want to know, is it going to open up or down? We can do that as well. Let's first plot this vertex, -2. Now we're saying these are all going to go by 2's. The y-axis is going to go by 2's and the x-axis is by 2's. So this is -2. Halfway would be 3, so it's going to be half of that. There's my -2.5, and then I got to go up 6.25. So 2, 4, 6, and we're going to be just a little bit above that. It's probably right about in there. And because this is negative, so since our A number here, our A is negative, it's going to open down. So it's opening down because A is negative. -1/5 in front of your x squared, that's your A number. So we know it's going to open down from here. Now can we use that, A number parent pattern? You can, because I can go one each way. It might be a little more challenging to figure out this because of the decimals. Remember, we're at a 2.5 here. So 1 would be about halfway in here. And then we'd have to go down about 1/5. So this is going to be quite wide. It's actually be much wider as a parabola here on this one. This one might be better if we were to, figure out some other numbers to plug in for this. So if we figure out some other numbers to plug in for this, and obviously good to have a little more space here. But if I plug in 0, that's an easy one we can do like we did over here with these two. What's our y-intercept? It is 5. So I know that 0, 5, there's 4. So this is 2, 4, 5 is going to be right here. So that's one I definitely do know. And my axis of symmetry is right here. So basically, on the other side of this, so how far away is that? This is 2.5 away. So 2.5 away this way would be actually at 5. So remember, this is going to go 2, 4, 5 would be halfway this way. So it's going to be right about in here. And so you can see that's kind of the way the parabola is going to be going. It would be nice if we can maybe get one other number. If we plug in 1, that might not be too hard. Actually, this would be 2. If we plug in 2, that might not be too hard to figure out. So if we did plug 2 here, that's going to give us 4. Let me see if I can figure out another one. Maybe if we plugged in 5, that might be a better one. So I'm going to plug in, if I plug in 5, which is going to take us at, there's 2, 4, 5. So I plug in for x is 5 right here. So I plug in 5 here, that's 25. And 5 goes into 25 5 times, making this a -5. That's going to make this -5 also. And then I have a +5. So the -5 and +5 cancel out, -5. So at 5, we're going to be going down to -5. There's 2, 4, 5. Right there's another point. And right now, again, we're basically 2.5 away here, then 5 more is 7.5 away from from this. So 7.5 away from that. This is at 2.5. That's going to be at 10. So all the way over to 10. So we got 2, 4, 6, 8, 10. We come down, it's going to be right about in here. So that's what we got on that one. Going to come up from here. Come around to the vertex, that's our highest point then. And then keep going down. And put arrows on the ends. Don't forget to always put the arrows on the ends. Alright, so I'm going to have you try number 6. Number 6, you're going to start with finding the vertex. This one's a little bit easier, it doesn't have the fraction. So find the vertex and then plot that vertex. You can do the axis of symmetry. On this one, realize that on the x-axis, these are going by 1s, and the y-axis, they're going to go by 2s. So everything on the x-axis will go by 1s, but everything on the y-axis, make it go by 2s. So try this one, number 6, on your own. And actually, you know, before you do that, I did not go over the domain and the range. I forgot about that. Let's come back to number 5 real quick and do that for 5 and 7. What is the domain and the range? So the domain is always going to be all real numbers. The range is always going to be based on your y-coordinate. It's going to be greater than or equal to -1. So that's what we're going to see. Domain, all real numbers. Range, y is greater than or equal to -1. This one, again, domain is going to be all real numbers. It's everywhere, both left and right on the x-axis. But the range is only going to be less than or equal to where the y number here is, which is 6.25. Which they're doing the 25 over 4. That's what I found down here. 25 over 4 is the same thing. But you could do 6.25 is just as good. Alright, so go ahead and do number 6. Pause the video, do that, and then also try to figure out what the domain and range is of that one as well. Okay, so for the vertex, you should have got the ordered pair 2, -9. When you find the x-coordinate opposite of b, so negative times -8 over 2 times 2, that's going to give you +8 over +4, which is +2. So plug 2 into your function for x in both places. And so we're going to get 2 squared, that's a 4. So we're going to get, and this is going to be a -16 here. So 2 times 4 minus 16 minus 1. So it's going to be an 8 minus 17 when you put the two negative numbers here together. And 8 minus 17 is -9. And so when you plot that point, so you're to 2 for x, it's 1, 2, -9 is 2, 4, 6, 8, -9 is going to be down here. So that's where your vertex is opening up. It's opening up from here. Since A is positive, it's going to open up. And you can find your -1 could be your y-intercept, which would be right here. So there's one point you can plot. You can also do the parent function, the A number parent pattern as well on this one with just A equaling 2. So your graph should look like this. That's a much nicer curve when they do it from the computer generated. So there's our vertex. There's our 2, -9 point. Here's our y-intercept, -1. Again, that's just 2 away this way, so 2 away that way. You can also put it at -1. You can do a parent function pattern. You can kind of get, so we got this one's 2 away, so we can see if I did 2, I would find that point there, wouldn't I? So the pattern would be 2 would be squaring to its 4, then 2 times 4, that would be 8. So we'd have to go up 8 from here. So again, this is going to be 2, 4, 6, and 8 going by 2s. And then we can do it by 1 right here. 1, it would normally go up 1, so 1 times 2 is 2, so we're just going to go up 2. We can put it right there. Go 1 this way, put it right here. We can do 3 this way or 3 that way. Remember 3, we're going to be squaring that, getting 9. Multiplying that by 2 would be 18. So 1, 2, 3 this way, we go up 18. So 2, 4, 6, 8, 10, 12, 14, 16, 18 would put us right here where that arrow is. On this side, same thing. The domain and range, our domain should have been, you should have said it's all real numbers just like the other one, but the range is going to be greater than or equal to, y is greater than or equal to, since it's opening up, the number right here is -9. And so that's what you should have for the range. So domain, remember, is all real numbers for every quadratic that we graph, every quadratic function that we graph. The range is going to be based on your y-coordinate of the vertex, and if it's opening up, it's greater than or equal to that. If it's opening down, like this one was, it's less than or equal to that. All right, let's pause here for our joke of the day. So when you're cold, what's the best part of the room to go to? When you're cold, what's the best part of the room to go to? A corner. It should be 90 degrees. That's a math joke, of course. More geometry than algebra, but it's still a math joke. So since a corner is always going to be 90 degrees, a right angle is 90 degrees. All right. Let's go on to our maximum and minimum values. So max and minimum. So a lot of times we say max or min for describing these. And that is simply, again, just is it opening up or down? If it's opening down, we're going to have a maximum point at the top. Our vertex will be at the top. If it's opening down, it's going to be a minimum point for the shape down at the bottom. So most of the time, I think when we see parabola shapes in the real world, we're going to see them more opening down this way, because you can see an arch, doing this. Like a ball bouncing, a ball is going to bounce in a parabola shape like that. So we do see more maximum points. What's the highest it's going to get? That's our maximum. That's a very applicable one for real life. But we still see that the ones that open up have a minimum point down there at the bottom. And that's also there can be real life situations there as well. All right, let's move into our extra practice here for 8 through 13. Page 259 there on your journal books. Just says tell whether the function has a maximum or minimum or maximum value, and then find the value. What is that value? Okay, so first of all, we need to find and determine. I'm going to do number 8, 10, and 12. So I'm going to do the even ones, and I'll have you do the odd ones on the page. So first we need to figure out which direction is it opening, and then figure out the y-coordinate of the vertex. That's all we got to do. So the direction that it's opening will tell if it's a maximum or a minimum. Because remember, and I can put it maybe over on the side here just to kind of keep it in front of us. So I put it over here on the side, like the shape of this parabola like we saw. If it's opening up like this, do the red. Or if it's opening down, that means we're going to have, it's opening down, arrows are pointing down, that means we have a maximum point up here. But if it's like this one, do it blue. If it's opening this way, where the arrows are pointing up, it's opening up, that means our vertex is down here at the bottom, and we would have a minimum point. Put min for that one. Okay, so keep that in mind. So the direction will tell us if it's a maximum or minimum, and then the y-coordinate of the vertex would tell us that value that the maximum or minimum is. Because again, what's the y value? The y-axis here is where is it on the y? That's how high it's going to get. So first of all, in number 8, we can see that the a number is a negative number, so it's opening down since a is negative. So its vertex is at the bottom. It's opening down. I should say at the top. I said down, didn't I? This is at the top. I messed that up right there. That should have been top. So if it's opening down, its vertex is going to be at the top. And so that means we're going to have a maximum value because the vertex is at the top. Negative, it's opening down, vertex at the top. What's the y-coordinate of the vertex? Well, in order to find the y-coordinate of this vertex, we're going to have to find the x-coordinate first. So we do that just like we did before with negative b over 2a. So don't forget about that here. So we're going to have to figure out our x-coordinate first. X is equal to negative b over 2a. That will give us the x-coordinate. Then we plug that in to find the y-coordinate, and that's will be our value for this case, the maximum value. So for the actually, you know what I wanted to do? I'm doing these ones. I'm doing the odds. You're doing the even ones. I got confused myself. Anyways, I showed you the first part of number 8. I'll have you come back and try number 8. So for number 9, I'm going to do the even or the odd ones. You'll do the ones that are even. Okay, this one opens positive here, so it's going to open up. This one's opening up. So opening up, we're going to end up seeing we're going to have a maximum. So this is going to be our vertex is at the bottom. This one's at the bottom. Vertex is at the bottom. And so we can see right there, we're going to have a minimum value. And then the x-coordinate, got to find out what x is here. So b is 16, so it's negative 16 over 2 times a. 2 times 8. So that's going to be negative 16 over 16. So that's negative 1. Negative 1. We're going to plug in negative 1 into our function to find the y-coordinate. So now that's will give us our answer. So the y is equal to 8 times negative 1 squared. And then the next term, 16 times negative 1, then minus 2. So negative 1 squared is 1. 1 times 8 would be 8. So that's 8. This is going to be negative 16. And this is going to be, oops, not equals. This is going to be negative 2. So if I take 8 away from 16, it's a negative 8. Negative 8 minus 2, that should be negative 10. So negative 10 should be our number right there. The minimum value, it's negative 10. All right, number 11, the direction it's opening because our A number right here is negative. So again, it's always about the A numbers. So this one is positive, this one is negative. So since it's negative, it's going to be opening down. So vertex, if it's opening down, the vertex is up on the top. So that means we have a maximum value for this one. It's a maximum value. We need to find the x-coordinate so we can find the y-coordinate, and that will be our value. Our maximum value will be that number, which is the y-coordinate. So our x here on this one is going to be 7 is b, so negative 7, 2 times negative 7. So negative 7 over negative 14. So that's going to be a positive 1/2. We need to simplify that down to a 1/2. So I got to plug in 1/2 to find out what my maximum value is. So y is equal to negative 7 times 1/2 squared plus 7 times 1/2. So we got to work with fractions sometimes. That's just the way it is. So 1/2 squared, we square the 1, we square the 2. So this is going to be negative 7 now times a 1 over 4. 1 squared is 1, 2 squared is 4. And then 7 times a half, you can think of this as 7 over 1. You're going to multiply 7 times 1 on top. That's 7 over 2 plus 5. So now this negative 7 times 1 here is going to be negative 7/4. So negative 7/4. Let's change it all into fourths now. So I need to multiply this by 2 to get a 4. So 14/4. So plus 14/4. And then plus need to multiply this in order to get fourths. I'm going to need to multiply it by a fourth. This is 5 over 1. So 20 fourths. 20 over 4. Sorry that this is getting a little small in there. So numerators, everything is a 4 on the denominator. Numerator is what we have to add or subtract. So take 7 away from 14, that's a 7, plus 20 is 27. So we're seeing it's going to be 27 fourths. So that would be fine right there, 27 fourths. The way they put the answer is in a mixed number form. I would probably prefer it as 27 fourths instead of 6 3/4. Or you can make this 6.75. That's another way you could say it as well. So we could have said 6.75 as also an acceptable answer on that one. I probably would have left it at 27 fourths myself. Number 13. Okay, as far as which way does it open? Right here, based on our A number, it is negative. So since it's negative, it's going to open down. If it's opening down, that means our vertex is at the top. If it opens down like this one, so this one's opening down, and this one is opening up. So since opening down, vertex is at the top. It's a max value then for the vertex. So maximum value. That's the first thing to determine. And now we got to determine what the number of that maximum value is. Let's find the x. So x equals first. Always got to find x before we find y on these. So I'm going to do opposite of b. So b is 1, so it's going to be negative 1. Over 2 times a, it's a negative 1/4. So it's going to be negative 1. Let's see. We can cross cancel, and that's going to be a negative 1/2. So we know it's a positive number, and we can just flip this upside down. It's going to be positive 2. Remember I said this before. We could have said 1 divided by half, which is the same thing as saying 1 times 2 over 1, which is 2. So it's just going to be 2. So 2 is what we got to plug in. So y equals negative 1/4 times 2 squared plus a 2 minus a 6. So that's going to be 4. So it's going to end up being negative 1/4 equal sign. Negative 1/4 times 4. And then 2 minus 6, we can do that right now. That's going to be a negative 4. I can put this over 1. I'm going to cross cancel 4. That's going to leave me with a negative 1 minus 4, which is going to give me negative 5. So our maximum value here, negative 5. Alright, so go ahead and pause the video. Now you're going to finish up number 8. I started that one for you. It opens down. So we saw it as a maximum value. Just find what's the y coordinate so you can figure out the maximum value number. And then do the same thing for 10 and 12. And I'll show you the answers there once you're finished. So pause the video and then play it to check your answers. Alright, so hopefully you finished 8, 10, and 12. Let's check our answers here. So for the x-coordinate of the vertex, you got to find that first. That's going to be a 5 over negative 1 eventually. So that's going to be negative 5. We're going to plug in negative 5 here. That's what you should have plugged in. So when you do that, you are going to get a fraction eventually. So I know this one might have been a little bit more difficult because we do have this 1/2. So we're going to get 5 squared, or negative 5 squared is 25. And then basically it's going to be 25 times 1, which is negative 25 over 2. Negative 5 times negative 5 is 25, and then you have your 2. So now you want to change everything into where it's got 2 at the bottom. So I did add these two numbers together here. So that's what you're seeing me doing. 25 plus 2 is 27. So we got our fraction here, and then I need to multiply by 2. 27 times 2 is 54. So 54 over 2, And if you take 25 away from 54, then we're going to get 29 over 2. You could have also done it where you could have gotten this to be 50 over 2 and 4 over 2, and then subtracted that, and 25 plus 4 more is 29. That's also going to work. Again, I would probably keep this one right here as 29 right there. I'd probably leave it like 29 over 2. Again, they make it a mixed number, 14.5. It's the same thing. Or you could say 14.5 is also acceptable. 14.5 works as well. Number 10, the way this opens, since it's negative, it's going to open down. So vertex is, again, I blew it on that one too. I think when I was writing this down, somehow I was confused. Vertex is at the top, so it's opening down. Vertex is up on the top. Again, this is supposed to be top here. And then the x-coordinate first. So this is going to be a maximum on this one. X-coordinate is going to be 4 over negative 2. It's going to end up giving us negative 2. Should have put that maybe in here. It's going to equal negative 2. Let's put negative 2 there. So we're going to plug in negative 2 in for x. So that's going to give us a negative 4 then. That's going to give us a positive 8, then minus 7. And you can do 8 minus 7, that's 1. So negative 4 and 1 make negative 3. So negative 3 is your maximum value. And number 12, the way this opens is it's going to be opening. I completely messed these up here. This one's not the top, this one's the bottom. Opens up. No. It's going to open up, yes, it's opening up, but when it opens up, it's down at the bottom. And it might be good that I even just did that, because that's like the most common thing. It sometimes just goes against what we think. When we think up, we think top. When we think up, we think way up high. But it's actually, the vertex is down at the bottom when it's opening up. The arrows are pointing up, opening up, but the vertex is actually at the bottom of it. Y-coordinate, so that way if it's opening up, it's a minimum. We know it's a minimum at this point, minimum value. For finding y-coordinate, first get the x, negative 1/3. We got to plug negative 1/3 in for this. So when we do that, we're going to again square top and bottom. It's going to give us a positive 1/9, and then 9 and 9 can cross cancel. Here we're going to see 6 and 3 cross canceling, giving us a negative 2. So this is going to be 1 plus 2 once we put these two numbers together. Take 2 away from 4, that's going to give us that 2. This 1 is from negative 9 times 1/9, so 1 plus 2 should be a 3, should have got 3. Now there's more than one way I could have done this. You know, I did this way. I figured out, I added these numbers, or actually subtracted them really, combine these two numbers first together, and then as I'm working on this, simplifying this, I'm putting these two numbers together as well, and then I can put those two together. Alright, number 13 we did, and now let's go on to 14. 14 is our final question, and it's a real life question, a real life situation question, talking about a rocket. So we have this function h equals negative 16t squared plus 250t. Notice you don't see x or y in this. They use t instead of x because t is going to be represented by time. The h is going to be represented by height. So h is height in feet, and t is in seconds, time in seconds after the rocket's launched. The rocket explodes at its highest point. The highest point is the vertex point. Remember, the highest point is our vertex. That's always our highest point. So letter A says, when does the rocket explode? The rocket would explode. The number for that would be the x-coordinate of the vertex. That's the when, because that would be your x-coordinate, or the t, the time. So that would be how long it would take for it to explode. At what height does the rocket explode? That's the y-coordinate. So your vertex in this one is kind of like this. It's more like t comma h in this sense. T comma h. So you have your time. That's going to be how long it's going to take for the rocket to explode. Your height, how high was the rocket when it exploded. So using our function here, we're going to be doing the x-coordinate negative b over 2a. So start with that. So x, I'll say t actually equals on this one since it's t. So t equals negative b over 2a. So b is 250, so negative 250 over 2 times negative 16. So negative 250 over negative 32. We're going to use our calculator. We know this is a positive since negative over negative is positive. Let's bring up our calculator. 250 divided by 32 equals 7.81. 7.8. Do we round that to 1 or do we round it to 2? I should leave it at 1. 7.821. So that would be how long? So when does the rocket explode? About 7.81 seconds. That's how long. At what height does it explode? We got to find now the y coordinates. So we got to plug this into here. So it's going to be h equals negative 16 times, so here's our t, so it's 7.81 squared plus 250 times 7.81. So we definitely want our calculator again to help us figure this out. So first of all, what's 7.81? So we can say this squared, if I just hit the squared button, I'll get that, 61.04. So negative 16 times 61.04 plus, and what's 250 times that? So again, when we say 250, I'll just put it back here, 32 to get it back to the original. And I say times it by 250. So times by 250 equals 1953, 125. 1953, 125. Yeah, let's go over here, multiplies negative 16 times this number. Oops. So I'm going to go ahead and put let's clear this. So we get 250 again, divided by 32 to get that original 7.81 number on there. We squared it, and now I want to multiply it by 16, so times 16. Now that's a negative number, negative 976.56 will be enough. So negative 976.56 plus the 1953, 125. So basically I need to subtract the 1953.125 minus this number. So let's go ahead and clear it. 1953.125 minus 976.56 equals. Is that right? Had to have been. So it's like right there in the middle. That was like halfway. So 976.57, we can call it. It was 956. Where'd that go? Oh, I got rid of it. I'll have to do that again. Bring it back up just to be sure. Let me just do this one more time. 53.125. 1953.125 minus 976.56 equals 976. Yeah, what's 76? 56. So 976.57. So at what height does the rocket explode? About 976.56 feet. Or I put 57 feet, close enough. Alright, so that concludes our lesson here on 8.3. And you guys have a great rest of your day. I'll see you on the next lesson. Take care.